Is time series data crushing your database performance? InfluxDB handles millions of data points per second with a database built specifically for time series workloads. Thousands of developers have already switched for faster, real-time insights. Ready to see the difference? Visit influxdata.com today.
Hello everybody, I'm Olivier Pope, an InfoQ editor, and I have in front of me Marcin. Marcin, please introduce yourself.
Hey Olimpiu, my name is Marcin Grzejszczak. I've been working on the Spring and Micrometer open source teams for the past decade, mainly focusing on the topic of contract tests, so Spring Cloud Contract, continuous delivery deployment, and Spring Cloud Sleuth, so distributed tracing, and recently, for the last couple of years, Micrometer observation, and Micrometer tracing mainly.
Okay, so all the cool stuff that happened in the last decades.
You said it, I did not.
It's little getting close now. We started from a monolith, blaming how ugly it is with the monolith, and then we realized that at points monolith is good, at points microservices are good, but what's necessary always, it's to know what's happening under the hood.
Yeah, absolutely. And, recently I started doing mentoring sessions, and in one of the sessions I had, somebody said that they're planning their career and they don't know what to pick. And they said, yeah, maybe microservices is the way to go. And I'm like, if you can't write proper code in a monolithic app, you'll make it even worse in a distributed one. So I am absolutely not surprised that with the emerging of the trend for microservices, people thought that certain principles do not matter. It's quite the opposite. It's always the principles that matter. And if we do not know those, then if we're going to distributed systems, we'll make it far worse over there.
Yeah, I agree with that. Lately, I spoke to two of the pioneers of microservices, or no, not microservices, but distributed systems. One of them was Sam Newman, which even though everybody might call him the father of, he said he was in the room when the term was coined, but he was not actually the one making the term, but everybody knows his book on microservices.
Yeah, fantastic book.
Yeah, well, the new version is coming this autumn, so... And the other one is Luca Mezzalera, that is more or less the same, again, father figure when it's about micro frontends, and everybody's in agreement. Not always micro frontends or microservices are the best choice, so it's better to see what you actually have and what are the trade-offs that you're embracing while doing that. But that's a whole different story. We have a decade, let's say, of microservices, or when it was adopted, and what it seems that's happening in any of the distributed architectures patterns, whether it's micro frontends, microservices, data meshes, it seems that some kind of consolidation is happening. People are understanding what needs to be done and all this kind of stuff. And one thing that I see more and more, and I'm very happy about it, is open telemetry. So observability is coming a lot upfront as one of the measures that are needed for technical people to really understand what's actually under the hood and understand more or less what's the impact for the end customer. So
the
user
experience. The observability, right?
Yes, exactly.
Mm-hmm.
And this is a big chunk of what to spend in the last period. Well,
yeah, actually observability, I spent the last 12 years, more or less. Because before joining back then Pivotal, we were creating certain open source projects that also involved distributed tracing. So part of that was donated then to Spring Cloud Sleuth. So yeah, for the past more or less 12 years, I've been working on observability. Consolidation, I do see that. However, I see that quite a few people are mixing terms, which actually Olympia you did, because let's say instead of saying observability, you said open telemetry, which is the, let's say, elephant in the room here, obviously, because open telemetry was founded way after, for example, OpenZipkin was set up, which was and still is a service that allows you to visualize latency between communication between different applications. And it also involved a standard for header-based tracing context propagation. So let's use proper terms here so we're on the same page. Regardless of the tool you're using, it's the observability that matters. I fully agree that regardless of whether you have microservices or a monolithic application, if you do not have proper metrics or in general proper observability, what do you know about your app? You can't answer any question, really. So business comes to you as a department and says, I think our app is slow. How can you say that if you don't have any metrics? Like, is it slower than, yesterday, an hour ago? And how slow was it an hour ago? What does it mean it's slow for us? During the mentoring sessions that I told you about, one of the people told me, hey, in our company, people want to rewrite Java to Go, Java apps to Go apps, because Java is slow. This is what they say. And I'm like, what? How did they measure that? What does it mean that it's slow? Do you even have metrics to measure that? But let's go even further. You actually touched on this topic with microservices, that sometimes it's not a good idea to start with microservices, but it's often a good idea to ask proper questions before we decide on anything in IT. Like, you want to rewrite from Java to Go? Fine. Do you have people who will support it? How many people know Go? Do you have proof that it's going to be faster? Let's ask ourselves a question. Is it even a problem that it's now in Java? So I thought that we are past this, because I did this mistake, like that was around 12 years ago, that I went to a conference and I saw MongoDB, and I'm like, wow, this is amazing. And I came back to my job and said, we need Mongo. And my manager said, fantastic, well, for? And I'm like, we need to store JSONs. So that's what Mongo does. And my manager said, we don't have Mongo at this point. So will you be the one who's going to set it up for all of our environments, including production? Will you support this? Will you set up in a high availability fashion? And then I said, you know what? PostgreSQL is great for storing JSONs. So there's this, I thought that this fashion-driven development or conference-driven development is gone, but apparently still it's not. So even though we are a decade in, or more than a decade in, the microservices approach, some things are still the same. So I think we need to continue repeating certain obvious facts and certain truths, because there's rotation within the industry, and apparently we just have to keep repeating things.
That's for sure. Thank you, first of all, for clarifying the fog that I produced. I agree with you. Observability is very important. In the end, yes, there were two standards, and now OpenTelemetry is only one in that regard. And that was one of the considerations I was mentioning. But anyway, Java is for a long time, and I think it will remain for a long time, one of the linguas francas of the internet. It has pretty much everything. It grows a lot, and now with everything that happens with the cadence of having 2 releases per year, you see it adapting, and definitely it's important to understand what's happening there. So how did you see the evolution? As you mentioned, you were here in the last 12 years in the observability space. How did it evolve during this period? How do you see it? Do you think the direction that we are currently at, is it appropriate or still to be improved?
That's a great question. And I was there. It's like a quote from Lord of the Rings. I was there 10,000 years ago at the very beginning when there was just Zipkin. And I've been there with Adrian Cole. I'm saying hello to Adrian and all the vendors. We're in the same room discussing, doing workshops related to observability. Then Open Tracing was founded, as far as I remember, which tried to solve certain problems. But I think the biggest issue with Open Tracing was a lack of backwards compatible changes. So constantly things were broken. Then we had Open Census that tried to fix the same thing. And now you have the merge of Open Tracing and Open Census, which is OpenTelemetry. Has it evolved in the proper way? I have strong opinions on that. So if you are interested in me presenting those opinions, then I can do it, of course, because I think that it tried to fix the problems that wasn't there in the first place. The order of actions being taken with open telemetry was very interesting to me, because what I think is the most important is agreeing on things that go over the wire. So the protocol is the most important. There was already one, so B3 from Zipkin. So W3C was created. Okay, fair enough. But the first thing that was done was the API creation of how the API should look like when dealing with spans and other signals, whatever. That was curious to me because, like I said, I thought that the protocol is the most important. Then I think the second most important things are semantic conventions. But everything was done in the opposite direction, and I don't want to go into, let's say, big details of problematic political discussions, political in terms of politics within the space that we're talking about, not the politics as such. Because it was very bizarre to me when people in the Slack channel of CNCF were asking about Micrometer, and let's say people moderating, I don't know if it's a good word, moderating that space from open telemetry, were asking people not to ask questions about Micrometer in this Slack. That was very bizarre to me. All in all, I have never had any problems with any competitors of the libraries I've been working on, the companies that I've been working in. I think there's space for everybody. We're, in general, very kind and open-minded people. I've been talking to and instrumenting frameworks that are direct competition for Spring, and I had never had any problem with that. Also, Micrometer observation, tracing, metrics can work with OpenTelemetry, which means that we are very open to working with them, but I wouldn't say that the willingness was mutual. And I think here we can put a full stop.
Yeah, let's leave politics to the politicians. So the rest is politics, and we'll keep on the techie side, because I think that's
Absolutely
better. So currently, would Micrometer be the way to go if I have a Java application, or I don't know, maybe even more than Java application, to instrument it to go towards observability? Or what do you say?
So it all depends. And then you should say it depends on what. So I think that Micrometer is a very mature project. I think we are highly driven by the community, and we very carefully work with the API. So we do our best not to break any compatibility. And I think we've been very successful at doing so. Obviously, I'm biased because I work on the project, but I think that's a very good starting point, especially with the Micrometer observation API. I think that's something very nice that we built. Maybe I shouldn't brag about this, but I'm very, very happy about what we built, because it completely inverts the way you think of doing observability. On the other hand, we support quite a few frameworks already, which means that this is completely transparent to the user. Because if we think of developers writing business code, often is the case that they do not have to even instrument anything by hand. If there is a critical part of the business process that they want to separately measure in such a way that it's time-based, then they can use the Micrometer observation abstraction, because a timer, a span, they are very similar in concept. So that they can instrument once and they have multiple signals there. However, I would use the whole Micrometer portfolio to do business-related measurements of your application, which you have to do by hand, because this is really dedicated to your business. So from the point of view of technology, you can't know upfront that, for example, the number of cars that you have currently sold in the last minute is the metric you want to have, right? And basing on that, you should have alerts, dashboards. You should talk to your business to answer a question: what does it mean that our business is doing well? What kind of a metric is defining that? Let's say that you have great technical metrics, fast responses, everything is awesome, but your business is in a terrible state because, for example, from the business perspective, the metrics are showing very bad results, right? So if you do not know the answer to this, then it means that you don't have proper metrics.
Okay, so more or less what I understand from what we discussed until now, and one of your previous points is that out of the box, Micrometer provides you let's say the plumbing, where it just looks at the metrics that you should care when looking at the way how the application runs from a technical point of view. Probably memory and connections and so on and so forth, the bread and butter of what it actually means, what the framework will actually bring to you. And then you have the opportunity to think like a product developer, where you're thinking about the benefit for your business. And that's something that you should instrument and make sure that it makes sense for the business that you're actually running, right?
Absolutely. So it means that the way I clarify my thoughts is not that bad. But I really liked what you said as a product developer, especially in the age of AI, let's say. The fact that you know how to code doesn't mean a lot. I mean, it's critical, especially with the security vulnerabilities that the vibe coding approach gives you. Or in general, so recently I've been to a conference where quite a few presentations related to AI, most of them related to security. The speakers were showing different data related to security of the AI-generated code, and the results were terrifying. Anyways, product developers. So your weapon right now is knowledge of the business, because AI doesn't know it yet that well, nor can it communicate with the business as well as humans can. So I think you put an emphasis on a very important thing. And one of the key things as a product developer is to know that the product you're building works fine. So in order to answer this question, always ask questions like why, how, meaning what does it mean that my product is working fine? How can I measure it? When does it mean that it's not working fine? What can I do to fix it, to remediate those actions, etc., etc.?
Yeah, for me, product developer is something that I'm working for a long time. So probably as long as you worked on observability, I worked on the product development because that was the main challenge. Usually developers came and they were very technical. They wanted to code. They didn't care about it. And they just said, okay, somebody else has to come. So more or less, they wanted to be code monkeys where somebody is providing them the formula or anything like that, but they didn't understand the impact. And that's why I'm looking that much into observability, because that provides you a laser cut through everything. And then that can provide the feedback how the actually users are behaving. And that allows you to have a very quick feedback loop. But still, I think what's odd is that there is a lot of data, and which is the very important one. So that's why I think it's important, the point that you had, where, well, obviously, if you're driving a car, you want to have you make sure that the gas is full and all these kind of the things that are happening, but then it's important to get to the destination. And I think that allows us to drive in the right direction. What would be your advice into using Micrometer? Okay, now probably less than some time ago, but one of the promises of microservices was you can live in a very heterogeneous environment where those that want to write Go applications for the sake of it, or Java applications or TypeScript or whatever, can all live together. Well, it's challenging because if you have a manager like the one that you mentioned earlier, your manager, you'll have other discussions. But some people are not that lucky. So how would Micrometer look in a heterogeneous environment? How are you ensuring that you have the context moving from one application to the other, so that you have a broad spectrum of everything that you have there?
Sure, that's a great question, and we can look at that from a couple of points. So, if we're talking about metrics, that's not really an issue at all because Micrometer gives you an abstraction over the metric collecting systems. So, if the TypeScript app is using Prometheus, Micrometer can also use Prometheus. So, metrics will be aggregated. So that's not the problem. I mean, you should use the same tags, you should use the same names, etc., right? So here we are quite well covered. Context propagation is very interesting because maybe for those who do not know anything about distributed tracing, the idea is that an identifier is set for the whole business process, meaning if the application takes in a request and then the request moves through 25 other different applications. So let's say we have 25 hops of requests. Then we will have one so-called trace identifier. So it's identifier for the same business process, regardless of who is processing that. And we have 25, at least, span identifiers. So span is in general, a single operation that is being processed. So the problem here is that in order for the identifier to be propagated, something has to propagate that by some means. So the way to achieve it is, for example, for HTTP to enrich headers. The only problem is that if I call it trace ID and Olympia calls it correlation ID, we have a problem because we will not be able to talk to each other and understand that we're talking about the same thing. This is why standards were formed for context propagation. There are different standards, obviously. For Zipkin, that was B3, and for W3C, there's a W3C one as well. So in terms of multi-language support, our job as a language or a tool is to ensure that we adhere to the standards. Which means that in the headers, if we put the proper data, we have to assume that the recipient will know what to do about this. So if micrometer tracing micrometer tracing just delegates work to a concrete tracer. So the library that does actual work. So that's OpenZipkin, Brave, or OpenTelemetry as such. So they know how to enrich or what kind of headers should be put into the given transport. Micrometer just delegates work to that. So if that work is done properly, then we can safely assume that if the TypeScript application knows how to propagate that further on, that the context will be properly passed on. So that's more of library work. Typically the user, so the end user, so the developers, they do not have to know about this nor care because typically the frameworks will take care of that.
Okay, so what I'm hearing from you is that the frameworks, to call them broadly, even though probably there are libraries and so on and so forth, are doing the heavy lifting as they should.
Correct.
And me as a user, I shouldn't care about that because everything is happening in a proper way. So as long as I'm using the same approach, whatever, let's say we start from the browser where we actually have the input. We have the first HTTP request that hits I'll not go into details, the first application in the chain, and then that cascades all over the place to all applications. As long as I'm using the same implementation across, so I don't know, the
same standard, the same context propagation format, yes.
Okay, so it's about the standard, and then everything is happening. And then the trace ID, it's passed through the headers as it should be, because that's the place for metadata. It's the place for the metadata.
Correct.
And that will allow me to see those things properly aggregated, and I'll see the call and then all that stuff. Okay.
Correct. Plus, because always the devil lays in the details. Remember what threads. So typically, I don't know how it works in different languages. I know about Java, but typically the tracing context, let's call it, is put in a thread local. And this is the way how it's then retrieved and pushed forward. If you're changing threads, that will be lost. normally, because we instrument things so that you do not have to, in such a way that we do know how to propagate things between threads. And so we created a Micrometer library for that called context propagation.
Okay, that changes the things. So back in the day, when all people were normal and you had like smaller applications and contexts like that, you had the logs because that was what you had at that point, and you had like the thread ID, and that was more than enough. But now, obviously, it's a multi-dimensional space. On one hand, you're looking at the distributed level where you're just moving from one context to another. So from one, let's say, microservice to another or another service. But then inside those, it might be the case that you're having different parallel calls, whatever, and then that needs to be taken into account as well.
Instrumental, correct. And let's keep the ball rolling. What about reactive apps? That's the
Obviously.
same problem. And I've been working with the problem of instrumenting reactive apps for 8 years, 9 years. And then Marcin Grzejszczak, so the lead of Project Reactor. Hello, Darek. Thank you so much for your help with fixing the problem in Project Reactor. We sat down for weeks and did an analysis with, pen and paper to understand like the flows, etc. And we've managed to hook in proper instrumentation into Reactor processing in the reactive streams as well. So we put a lot of effort into ensuring that people who are using Project Reactor, Micrometer, Spring, they know that things are working fine. And I don't remember when was the last time I had an issue filed about Reactor and re-instrumentation of Reactor. So I think we finally fixed it.
Congratulations. Well, surprising enough, Reactor is being used now a lot in the MCP space. Talking about hypes and everything. So I think it's quite important that it's working as expected, especially in the observability space. Okay, then me as a developer, will I have a easy life? And which are the boundaries? You mentioned before that you instrumented a lot of projects so that you have a plug and play, an out of a box functionality that is bringing the observability that we want. So that means that me as a developer, most often than not, I'll just take the library, drop it there, compile it, run it, and that's it. And I have to take care only about instrumenting the stuff that I should care about. So mainly the flow of the application that you don't have any kind of way of knowing. Is there anything else I should know, like, I don't know, odd cases that were not covered, they're very complex to instrument, or it's too complicated?
So multi-threading, that's for sure, because you can do some business processing with executor services and things like that. So then you use libraries like context propagation to ensure that the executor service that you're using is properly wrapped. Because how it works is before a new thread is created, we do a snapshot capture of the current thread local values, and then we restore them in the new thread. If you do it by hand, things will not work out of the box if you don't have the wrapper. If you're using frameworks like Spring or Spring Boot, then things should work out of the box because we auto-instrument them depending on what you have in the class path. So if you have Micrometer on the class path, there's nothing you have to do. If you're not using Spring, we instrument various components. So you glue it yourself anyways, typically. So you have to ensure that you're using our wrappers. And the most important thing is that the vast majority of instrumentations are done in the projects that we're instrumenting. So that's the big differentiator between the philosophy of Micrometer and other frameworks out there, because we believe that having one, let's say, God project that has dependencies on all projects out there in the ecosystem is unmaintainable. This is why I personally instrumented Apache Camel. So the instrumentation is there in the Camel. It's part of the code base, right? There's a bunch of other projects that we Resilience4j, for example, another library that has the similar approach. we believe that instrumentation should be there because when they add some new features, fix bugs, whatever, and they break the observability, they will know that immediately because it's in their code base. Whereas if you have a God project-like approach, which Spring Cloud Sleuth was the case, that's unmaintainable because you know that things are broken post factum. Because, for example, I instrument, let's say, Resilience4j. Resilience4j broke something, and I only know about that the moment when I upgrade their version. It's already too late because the users will not be able to upgrade to the latest version because my instrumentation is broken. This is why we completely changed the approach and decided that it's in the given project that the instrumentation should take place. Also because sometimes, especially in the Sleuth days, I had to do some hideous hacks to ensure that instrumentation takes place, that I retrieve the headers, I do some stuff with that, and I properly close it. Whereas if the instrumentation happens within the project, you can have access to package scope classes and things like that, right? So this is how it should be done, in my opinion.
Well, it sounds normal. This should be like electricity. If it works, you shouldn't care about it. Only if it doesn't work, then headaches are created. What else should I know about Micrometer or observability that I didn't ask at this point?
The key thing to remember about observability, especially in terms of distributed tracing, what you produce at the end of the day is data, tracing information or observability related information, because the same thing is related to metrics, but let's focus on tracing right now. Ingestion of the data costs money. The more data you ingest, let's say push for somebody to ingest, the more you pay. This is why I understand that there are frameworks out there that give you a lot of metadata, a lot of tags that you can set for your application. And that's great, right? Because you have more insights into what happens with your application when you look at traces. But on the other hand, remember that at the end of the day, there are vendors who earn money from that. And that's absolutely their right to do so. But the fact that you have a lot of tags implies big costs. This is why you should always think about that. Maybe, for example, with Micrometer, you have an option to have create a filter that allows you to post factum add certain tags or remove them. Always think about the cost, because if you add observability and then it turns out that you're paying gigantic bills for that, at the end of the day, us as developers, product developers, are only for the business to provide business value, thanks to which the company can earn money. If we don't have this at the back of our heads and we say, hey, we want observability, we want as much data as possible, and we do not calculate what the cost will be, then the cost can be much bigger than the gains, right? So what I'm trying to say is that as developers, regardless of the case, whether it's observability or not, our decisions can have very concrete impact on the business. And we should always think twice before we decide to do anything that can impact the business side. As far as Micrometer is concerned, please visit our website, micrometer.io, where you can find the docs. I think it was last year that we invested a lot of time in rewriting the docs and making them look much nicer. We value our users' feedback. It's invaluable to us. So please visit our issue tracker. So go to GitHub, to the Micrometer project, and provide any feedback you're willing to provide, because we want the product to serve you as well as it can.
Thank you for that. And from what I know, it's version 7, the current major version of Micrometer, or at least...
Version 7 will be the next major version of Spring. So right now we have Spring Boot 3.4 and Micrometer. Now we have 1.15.
Anything that you're excited on the roadmap that would be important in the way how the things are happening?
I mean, the most critical part of our roadmap is essentially following what the users want. So you can check our issue tracker to see what has the highest thumbs ups. If you want to actually ensure that what you care about is being done in the next minor, just ensure that the given issue has enough of thumbs ups. In general, I am thrilled that what the users want will be definitely addressed.
Thank you for that. So if we want to have our voice heard, it's important to promote it and do the thumbs up. Thank you for the insightful conversation, Marcin. All the best with everything that's coming your way.
Thank you so much.